Vectors and matrix operations, linear transformations and fundamental properties of finite dimensional vector spaces, numerical solutions of systems of linear equations, eigenvalues and eigenvectors, selected basic elements of linear programming. That is the course catalog description of a linear algebra course I teach from time to time. I'm not entirely sure who's supposed to get anything out of that. Certainly not my students, not at the beginning of the semester. It's just a bunch of words they don't know anything about yet.
It might be useful for some of your colleagues who want to have a list of the things that you're going to cover in your class, but it certainly isn't useful for students to know about what they need to learn when they take your course.
That's why I crafted some learning objectives for this course to put in my syllabus to try to communicate this better to my students. So here's how I phrased it in this course. To model and analyze discrete dynamical systems using concepts and techniques from linear algebra. To interpret questions about existence and uniqueness of solutions to systems of linear equations as questions about vectors, matrices, subspaces, and linear transformations. To communicate solutions to mathematical problems effectively using words and images. So still a little heavy on the jargon, but hopefully they give students a little better sense of what they'll be able to do when they actually finish the course.
Those are some really clear, well-crafted learning objectives, Derek. Those are really the foundation for something that we call backwards design. Backwards design is exactly what it sounds like. It's the reverse of what most instructors would actually use to develop a course. So most instructors would sit down and figure out what they're going to cover during the first week of class, second week of class, third week of class, and then start thinking about doing some kind of assessment, like writing an exam, to measure whether or not students met some kind of list of things that you wanted them to learn. And then maybe at the end of the semester, you'll reflect on that and look over the whole course. The beauty of backwards design is that it takes that process and reverses it. So we start out by writing these very clear learning objectives where we lay out what we want our students to get from the course. We then develop assessment tools to actually measure whether or not students met those learning objectives. And then we get to do the really fun part, which is design the activities both for in the classroom and outside of the classroom. And then maybe you can write your list of topics covered for your course design, for your course description in the course catalog, Derek.
Right. So the backward design process is a really fantastic way to put together a course, to build a course. And so we're going to spend the next few weeks in this course going through that process. So what can we look forward to this week?
We're going to hear from Stephanie Chasteen from the University of Colorado at Boulder. She's the outreach coordinator for the Science Education Initiative there. And she's going to talk about how to write really clear and effective learning objectives, how to apply them at different scales, from the course scale to the topic scale, some useful ways to categorize them, and then also how to determine whether or not a particular learning objective is appropriate for a particular learning goal.
So we're going to start with learning objectives, the first phase of the backwards design process. It can be a pretty hard phase. It's not easy to write good learning objectives. But once you've done that, then you've launched the backward design process in a really strong way.
Learning objectives that are clear and focused really help keep both the students and the instructors on task throughout the course. So after this week, we'll then be talking about assessment, which is the second step of backwards design. But for now, have fun learning about learning objectives.